Good afternoon. What a real pleasure to host this unique workshop today with more than 400 participants that should join us this afternoon. I'm Nathalie Gamin, your moderator today. For the ones who do not know me, I've been involved with ocean literacy for the past 20 years and surely look forward to moderating today's workshop on ocean literacy for journalists and science communicators. What a timely workshop to take place when we know that the Intergovernmental Oceanographic Commission of UNESCO holds this week its 32nd assembly, and more particularly celebrates tomorrow, on June 22nd, its Ocean Science Day. For the ones unfamiliar with this day, Ocean Science Day highlights priorities for new ocean science and technology benefits society and exploring the role of the UN Decade of Ocean Science for Sustainable Development, focusing on innovative and transformative ocean science, but also on knowledge for sustainable development. It is not a surprise to see our today's organizer, Mercator Ocean International, as one of its expert panelists to celebrate this Ocean Science Day at the IOC's 32nd Assembly. I invite you today to celebrate this special day, a day ahead, with our workshop. Please be ready to embark and get empowered to use the Copernicus Marine Service as a unique scientific source for marine-related data to write your stories, but also to generate the right visuals to illustrate them. In light of this, I invite you to follow a few housekeeping rules. First, I would like to invite you to enter your organization and country name when entering the session. I do see that's the case. To please ask your question about the workshop by Slido. The link will be made available in the chat box. And also, please use that chat box if you encounter any technical issues for our technical team to assist you. I think it comes on the next slide. Next slide. That's Slido, so I do invite you to embark. So please check your phone and copy that link. Let me introduce you, while you do that, to our first speaker today, with Andrea Ferreira de Carvalho, who will present you today's agenda. Andrea has a background in marine ecology, having worked mainly with deep sea ecosystems. Her main interests lie in science communication, cognition, and improving user experience. In Mercator, her role is to create adequate training for the vast community of users of the Copernicus Marine Service. Please, Andrea, welcome today.
Thank you, Nathalie. Thank you, and hi, everyone. It's a real pleasure to organize this workshop for you. Yeah, we'll go through our agenda for today. We have prepared a really nice session. I hope you all enjoy. To start with, I will introduce you to the Copernicus Marine Service. Maybe many of you are not familiar with this, with the program and with the Copernicus Marine Service yet. So I'll do that. And then we will have Spyros Pontilidis. I was gonna go a little bit more in depth on the marine data catalog of the Copernicus Marine Service. And he's also gonna be our ocean expert for today. He's gonna also show us, gonna tell us about a use case, more specifically for science community, but also he's gonna tell us about how you can use Copernicus Marine data in your stories. Why is it important to access the Copernicus Marine Service for that, and what kind of tools you will have available in there. We will also have a live demonstration of our MyOcean viewer by Elena DiMaggio, also from Mercator Ocean International. She's a Copernicus Marine Service user support manager, so she's really the right person to show you all about this visualization tool. And later on, we will have some practical exercises. So this will be the more practical part of this session today. We will really show you how to access the data on the viewer, how to extract certain data, and and to visualize it to support your stories. If you have a background in communications, or if you're a journalist, or if you're just someone active on social media, this could be really helpful for you. Also, speaking of social media, we'll have Simo Malis from Evenflow, who's gonna give us some tips on how to properly reference this information we'll extract. And so in between, we'll have certain Q&A session moments. Like Natalie said, this will be on Slido. So just don't hesitate, don't be shy, post your questions, we will address them. Thank you. Maybe I can just go ahead. So as I said, I will introduce you to the Copernicus program. If you're not familiar with it yet, the Copernicus is the European Union's program dedicated to Earth observation. It provides free, open access to data on the planet. And so the goal is to monitor the environment, monitor the planet on its whole, to be able to understand it better, but also to anticipate changes, also to learn how to adapt to what has been happening, what happens to us humans. So the program Copernicus is composed by 6 services, and they are all managed or operated by different entities around Europe. Today we will focus on the Copernicus Marine Service, which is dedicated to the monitoring of the marine environment. So next slide, please. I'll tell you a little bit more about this in a brief way about this service. So the way you can access the service is via our website, marine.copernicus.eu. And over there, you will have access to an extent online catalog of products ready to be used, download for you to, if you're from a research background, which are mainly our users, research, or policymakers, or businesses that are related to the blue economy. This is where you can access the data. So all these products we make available, they are scientifically approved. Besides products or data, you will have also indicators and also access to visualization tools, which we will show you a little bit more about it later on. So these products are ready to be used, so they are user-driven. We focus very much on that. So they have all the same format to facilitate the usage. And like I said, it's open and free. You only need to register to be able to download the data, but you don't have to pay anything. Next slide, please. So what kind of data can you find on the Copernicus Marine Service? We provide access to data on what we call the blue ocean. So this is more the physics side of the ocean. So everything related to currents, temperature, waves, the sea level. We also provide data on the white ocean. So ice coverage, thickness, all related to ice. And also we provide data on the green ocean. So this means chlorophyll content, this means nutrients, chemistry, all that has to do with CO2 levels and all of that. And next slide, please. And so our data, the data we make available, it's composed by 3 main sources. They come from 3 different sources. They are based on observations, so satellite and in situ measurements, but also model data. They cover a large, so they cover the real time. So right now, they cover hourly, and they also cover it also includes a reanalysis in time, so over a long period of time, so from today, 30 years back, and this is called reanalysis. And we also provide a forecast service, so within 10 days to the future. In terms of the geographical coverage, spatial coverage, we focus on 6 European regions, which you can see here on the slide, but we also provide data on the global ocean. And yeah, the next slide. Thank you. So yes, like I said, each service from Copernicus, it's operated or it's managed by a different entity. The Copernicus Marine Service is operated by Mercator Ocean International. We are initially ocean forecasters, but we don't. We rely on a vast network of data producers. So if you could just go to the next slide. We rely, so as you can see, we operate the system, but then we rely on a huge network of data producers, which we divide into thematic data assembly centers and into monitoring and forecasting centers. And if you go to the next slide, so the thematic data assembly centers, they collect, they are centers, they are 8 centers divided into different thematics. For example, the temperature, the sea surface temperature, the ocean color, so in different thematics, and they will collect data from other centers related to that thematic only, and then they will make it available to us. This and they will collect data related to in situ and to satellite observations, so only to observations. They will collect data real time and reprocessed. The monitoring forecasting centers, they will do the same. They're also separated by the different, so the 6 different regions plus the global data, and they will focus on numerical models. So they will develop and develop models, and they will make it available also to us, and some of them also make it available directly to the users. And so this has to do, in case of the numerical models, they assimilate the data that was recovered from the direct measurements and satellite observations to analyze the past, the today, and the forecast, to create forecast systems. If we can go to the next slide, please. As I said, in the website, you will find all of this I'm telling you about. But besides products, we also allow you to, so we also provide reports. Every year we publish the Ocean State Report, which is a summarized, so it's like a focus on the state of the ocean for the last years, but mainly on the most recent years. And over there, we also provide a more summarized version of the whole Ocean State Report, which is more applied to policymakers or to general public, also to someone who's a non-scientific, let's say. So also to you, this could be a very useful tool. So the summary of the Ocean State Report, that would be. We also provide indicators and global trends, global or local trends that you will be able to download from our catalog, and you can also use it in your communication or your research, etc. And I think we are going to the last slide now. Yes, I just wanted to give you an idea that the Copernicus Marine Service tries to cover a wide range of markets, as we divided it into more like society, environment, and also economy. So of course, the focus is on monitoring the marine environment, but we also try to respond to the needs of the society, be it security, coastal challenges, for example, protection on coastal areas, but also on economy, such as certain blue economy, more focused companies. So yeah, and that's all for me.
Many thanks, Andrea, for this very comprehensive presentation of the Copernicus Marine Service, and more particularly the role of Mercator Ocean International. That's really essential to get going with this training practical workshop. Let me ask you, ask the participants, you all, to use the Slido section to raise your question. Yes, I do see that's the initial questions we had scheduled, but let's go on with that, please grab your phone and copy the QR code for the Slido, please. So the first question is, where does your readership come from? Welcome to India, Netherlands, Europe, France, Spain. I've seen in the chat box that we had people from the US and South Africa. So mainly from Europe, the Northern Hemisphere, global South Africa, quite international. We do appreciate that. We do hope that everybody can get on and enter. I do see that in the chat box, we have people also filling out from Sri Lanka, Nigeria, Greece. So we do have two sources, but welcome to you all, definitely. And it does show that Copernicus Marine data raised international interest to generate storytelling and to generate the right illustration using science at its core. I do see that we have still participant typing. We have from Somalia, Ghana, Bangladesh, South Korea as well. We're international. Let's maybe move on to the second question. What do you expect to see from this workshop? I invite you to fill out the Slido. If you can't, yes, it will be easier if we have only one channel. Please go ahead. I do see that someone raised or mentioned from data to information. Definitely, that's the key, the core and objective of this workshop today, to provide you the right tool to write your story and generate the right illustration. So I do see that from the input we get in that most of you are looking for the same objective, to use concrete, practical tool to write your stories and illustrate your stories. That's great. And that feeds into our objective for today. Let's maybe get to our third question. What are the topics you are most curious about? And I think we have a list of topics coming, if I'm correct. Yes, you may enter: climate change, biodiversity, satellite, data visualization using my ocean viewer, marine algae bloom, awareness, pollution, renewable energy, wave energy, ocean. Andrea, I do see that most of the topics of interest will be responded today toward the workshop.
Exactly, yes. I think we did a good selection of topics as well. I guess these are also the topics that are, at the moment, they are more, on the news, I guess, right? Hot topics.
The hot topics, yes, definitely.
So,
so we're surely going to provide you some answers, or at least tips to tackle those issues throughout our workshop today. Let's move on. I think following Andrea's presentation, you might have some specific questions. And we do see that it is important, notably, that's a question that comes up regularly, the distinction in between satellite and in situ component. I think it's crucial to understand the distinction to move on with that workshop. Andrea, maybe you can provide us a reminder about this distinction, which is crucial.
Yes, so they are both called observations, but we normally call them observations, in situ observations and in satellite observations. But in situ comes from Latin, and it means in a place. So they are direct measurements. So often they are collected via gliders or temperature sensors, or a sort of tool that we put somewhere, like in this case in the ocean, and that we collect the data directly. Satellite observations are satellite imagery. So we use satellites. In this case, we use Sentinel satellites. It's a family of satellites. There's at the moment 5 or 6 Sentinels, if I'm not mistaken. And we also use satellite imagery from contributing missions, so other satellites that are also, their data is also made available for us to complement our data catalog.
Thanks, Andrea, for this very important clarification or explanation, I have to say. We're going to keep all questions. They won't be lost. Do not worry. I'm sure that the Mercator Ocean International team will publish after the workshop all questions with the answers, so everybody that participate today will have the proper and useful response. Let's now move forward with our workshop and see how we can integrate and use the Mercator Ocean International in your storytelling activity. Let me introduce you our next speaker with our ocean expert, Spiros Pandidis. Spiros is currently writing his PhD thesis on potential fishing zone detection with the use of remote sensing. He is an active researcher in the Marine Remote Sensing Group, specializing in data analysis. He is from the University of Agen. He is an active scientist. He has authored 5 peer-reviewed papers in international scientific journals, and he has achieved recently the 2nd place in the Copernicus hackathon held in Sofia. Spiros, welcome with us this afternoon. The floor is now yours.
Thank you very much for the introduction. I am Spiros Pandidis. I'm a member of the Marine Remote Sensing Group at the University of the Aegean. And together with Professor Konstantinos Topouzelis, we worked with various projects with Copernicus Marine Data. And today I'll try to give you 2 presentations. The first one is about a high-level presentation of the Copernicus Marine Data Catalog, together with some use case examples from applications from the scientific community. And after that, I'll give you another presentation with more specific examples of how journalists can use this kind of data to support their publications and for news generation purposes. Slide now. Thank you. Now, fitting to the spirit of the workshop, I'd like to start my presentation with an article for Forbes, for example. And through this, I'd like to clarify what I appreciate most from this service, from the Copernicus Marine Service. The article states that cleaning big data is the most time-consuming for time analysis applications. And from my point of view, this is very true. The first thing to do when we have our scientific question and plan our analysis is first to gather the data, find the data sources, and try to analyze them and break them in a format so we can incorporate them together into our models or whatever the analysis might be. And this is the most time-consuming thing. The 79% of time spent on data handling is actually very, very correct. And what I appreciate from Copernicus Marine Science is that it has a lot of variables, and when I can work with this data, then I know that they are easy to use. I can just download them, and they will be ready to access and ready to use, and I can incorporate them into my analysis very easily. Now we'll go on to a more high-level presentation of the products. We'll start from the high level of classification of datasets, and we'll move downwards to the product level. Now, Andrea, I gave you an overview of these classifications. I'll mention them in a little more detail. Basically, you have 3 major classifications: the blue ocean universe, the green ocean universe, and the white ocean universe. Can change the slide, please. Okay. The blue ocean products, as it was mentioned, it involves physical oceanographic parameters. Parameters like temperature, which could be either sea surface temperature, sea bottom temperature, sea surface density, etc. It could be information about the currents, geostrophic, barotropic, or tidal velocities, information about sea surface elevation or sea surface height, which is mostly referred into the catalog. It's the SSH that you see on the slide, which may either be measured above the geoid or above the sea level, and various and various other meteorological and sea state parameters like information about waves, products about waves, or the wind above speed. Now, the sources of these products can all be either from satellite observation, model outputs, or in situ measurements like buoys or scientific surveys. And at this point, I'd like to make one distinction because I think we'll talk about it a lot in this publication, and I think it's very important to understand this distinction. I'm going to talk through this presentation for two kinds of resolutions. The first one is spatial resolution, and the second one is the temporal resolution. Now, spatial resolution refers to the actual area of a pixel that covers in real surface of the Earth. For example, if I'm talking that one product has 1 kilometer spatial resolution, then what I'm really saying is that each pixel of that particular image will have, in real space, will cover 1 square kilometer of surface. And the level of the spatial resolution allows us to have more detail on our products or less detail of our products. And what we use varies from application to application. Temporal coverage, on the other hand, means the temporal step between each observation. For example, if I have a daily product, a product with daily temporal resolution, then it means that each observation, for each day, I have one observation. If it was weekly, then I would have only one observation for each week. So moving on, for the blue ocean products, no, I'm sorry, I can go back. Go back. No, thank you. For these products, the spatial resolution varies from 2 to 25 kilometers. The temporal resolution could either be hourly, daily, or monthly. And for some of these products, you could have a 10-day forecast in the future. And for all these products also, we can go back and see past 30 years. We'll have the Copernicus Marine Service has a 30-year time series, which the users can access, visualize, or download the data. Okay, you can change our slide, please. Now, for the green ocean products, these mostly refer to biochemical parameters. The most important one, I think, is the primary production, like chlorophyll concentration, which can be used to see and monitor algae blooms, or phytoplankton concentrations, products about the phytoplankton species, etc. Products like low and mid trophic levels, like zooplankton or micronicton concentrations. Another very important variable, dissolved oxygen in the C column. Various products of the optical properties of the water column, like remote sensing reflectance, the various absorption coefficients, the light attenuation coefficient, and the turbidity of the seawater. Information about the carbonate system, how acidic it is, if there's acidification in particular region through the pH values or the alkalinity, and the surface flux of CO2, and the concentration of various nutrients like nitrates, phosphates, or silicates. The sources are the same from the blue ocean products. Here we can have a high resolution, spatial resolution dataset from 100 meters to 25 kilometers. And the other technical aspects are pretty much the same with the blue ocean products. And now for the white ocean products, this mostly refer or only refers to subject related to ice and ice coverage. It could be either sea ice concentration, sea ice thickness, snow coverage, the age of the glaciers, or the temperature of the ice surface. For this universe, the white ocean universe, there are no available in situ measurements, only from satellite observation and model outputs. The spatial resolution could vary between 2 to 25 kilometers. And again, the temporal resolution could be hourly, daily, or monthly. Okay. When I was talking about the green ocean universe, I mentioned that we can have high resolution data of approximately 100 meters spatial resolution. Now, these products come from the source of these products is from the Copernicus Sentinel-2 satellite and the MSI sensor. These products can describe the very important ocean color variables like the turbidity of the water, the suspended particulate matter, or the chlorophyll concentration. And these products are available through our 20-kilometer wide strips from the nearest coastline across all European seas. And here, if we change the slide, here we can see the value. It has moved a bit, it doesn't matter. We can see the detail using this kind of data sets. We can, if we want to look for a small scale phenomena, we can use these data sets to monitor it in higher detail than we could do if we had lower resolution data sets. Now, when you log into the Copernicus Marine Service, you'll be greeted with this landing page. And if you want to access the ocean products, you need to click on the ocean products section. It is the first one of the 4 boxes that you see here. Okay, can I change slide now? Now, if you click here, it might be a little overwhelming if you are looking for something specific. You're immediately greeted with 275 products, and it can be very hard just to go through all of them to find what exactly you need. But fortunately, the service has a very intuitive filter function with many variables that can help you subset those options. For example, on the higher level, you could just select the universe that the dataset you try to find belongs. If you want but you can be more specific if you know exactly what you want. You can just select the main variable. For example, if I was looking to find the temperature of a specific region to gather data about the specific region, I would just click on the temperature dataset. For example, again, if I could summarize, I could subset those products further by the area of interest that I'm trying to looking for example, the Black Sea, or the temporal resolution of these datasets. If I'm looking for a specific date to see what the temperature was at a specific point, I would select daily products. And we have other various, the Copernicus offers other various filter functions like the source of these products, the processing level, if it is level 3 or level 4 products, and if it refers to either Euro directive or any of the 2 markets. Okay. After we filter out the unnecessary information in products and we find what we want and click on it, we are greeted with this kind of information. We see a screenshot of the product and also some information about it. The first one is the full name, which has some comprehensive information about it. Like, for example, this one is for the Mediterranean. It's about plankton, and it has daily and daily gap-free observation and monthly observations. The next one is the product identificator. Basically, it's a unique identification code for each product, which you can refer to. The source of this particular product, this one is from satellite observations, it could be from model outputs or from in-situ measurements. Spatial extent refers to the area. This is for the Mediterranean Sea with 1 kilometer spatial resolution. And downwards, we see the temporal resolution of the dataset, the processing level. This one is level 4, which means that it's gap-free. Gap-free means that if we had empty pixels due to cloud coverage or sensor errors, these are filtered in. So we have complete products with no gaps. And finally, it's the variables that this product holds. This one, for example, is mass concentration of chlorophyll in seawater. And now we'll see some other useful information in the Ocean Monitor Indicator section. Andrea spoke briefly about this too. Can we move another slide, please? So if you click at this box, you see various graphics and maps referring to ocean monitor indicators, which are trends and data of key oceanographic variables that are used to track the health of the global oceans. For example, here I present a map from this section from a Copernicus Marine Service about the mean sea level trends between January 1993 to August 2022. And I think it's a very powerful visual because when you present a map like that, you can show the scale of its phenomena. So if you observe the red color scale refers to rising levels of the sea level. And there are very few where the opposite happens. So immediately, if you state that we have a problem with the sea level rise, and produce a map like that, or communicate a map like that, you can immediately present to your viewers the scale of that problem. And other various graphics, like the one on the right, where it says that it presents the trend of the sea level across 3 decades. And we see that steadily each year, the sea level increases. From 1992, it has increased by 10 centimeters until 2022, I think, this graph refers to, with a 3.3 millimeter rise per year. And now I'll speak a bit, no, maybe I will not. It's the ocean visualization. If we skip another, okay, perfect, about the ocean visualization section. I'm not, and again, another slide, please. If we click here, we see the 3 visualization tools that Copernicus service provides. I will not talk anything about it yet, because we'll have another presentation in more detail after this one. So you can skip this page, please. Now I'll go briefly to some use cases from academia, and how these datasets can be used in bulk to produce various applications. For example, the first one I'll present is about fish distribution modeling with remote sensing data. So when we're talking about satellite data, you saw the spatial resolution that we generally refer to. And of course, we can't see fish with a spatial resolution of 1 kilometer. So when I'm talking about this kind of methodologies, we mean indirect approaches, meaning that we try to find the areas which hold the best environmental conditions that could help the aggregation of this population. These areas could be either favorable ocean circulation conditions, it's about the chlorophyll concentration of the area, or the sea surface temperature. And we try to model all this data to see if we can model the fish spatial distribution, and we can predict that. Can I move, please? Now, this kind of approaches need many proxies or indicators to work, to model with. And as we saw in the catalog presentation, Copernicus offers a lot of those variables. For example, the Sentinel-3 satellite mission can give chlorophyll concentration of very high resolution at approximately 300 meters at vast geographical scales. And the temperature, it also can be retrieved from Copernicus Sentinel-3 satellite at 1 kilometer spatial resolution. And this is an example of a product using that holds chlorophyll concentration from Sentinel-3 data. Okay, next slide, please. And these are some examples using this kind of data to produce anchovy biomass in the North Aegean and sardine biomass prediction maps again in the North Aegean. Okay, perfect, thank you. Other examples is the usage in aquaculture industry, specifically for precision fish farming applications, using again Copernicus Sentinel-2 and Sentinel-3 mission, as well as Copernicus Marine products. These products can be used to monitor fish farms remotely, and through specific algorithms, we can produce early warning systems for potentially harmful events. This could be algae blooms to chlorophyll concentration monitoring, possible anoxic conditions from measuring the oxygen level of the waters that could kill the aquaculture fish, or sudden temperature rises. Okay, thank you. Perfect. Of course, you can measure near real-time potentially harmful events like algae blooms. Here's an example which I'll go in more detail in my next presentation about seasonal assemblages in the North Aegean, where you can, using the Copernicus Sentinel-3 mission, you can see those assemblages in very high detail and see their movement through time. and how the phenomenon develops. And next slide. And finally, I want to talk briefly about the in situ measurements that the Copernicus catalog holds, which is it's not the prettiest for journalism purposes and communications, but I can assure you it's a very important component of this kind of analysis because they are the pillar stones for model building. In situ data are needed both for training the models so that they can we can see if we can predict phenomena and make applications. And also they're very especially important for model validation, to see if those kind of models that we produce are in line with reality, if they can be generalized and used reliably for applications. And the hard part is to find those data, because in situ data are divided between international institutes, and if someone would try to make a big application, they will need a lot of data and might be near impossible to gather them. And Copernicus, as a database that holds many of these data, access from across the Europe, it's very valuable indeed for this kind of model validation and model building. And here's an example about chlorophyll concentration algorithm validation for the Sentinel-3 mission that the laboratory did a couple of years back, using the Copernicus in situ data catalog. And here I think I end my first presentation. Thank you very much. We'll talk again soon.
Many thanks, Spiros, for this very comprehensive presentation of the Copernicus Marine Data Catalog. And I have to say, for our audience today, journalists and science communicators, it is very important to understand the options the catalog provides. You've gone through the blue ocean product, green ocean product, white ocean product, but the essential is the extensive usage our audience can have of the Copernicus Marine data, and very detailed, oriented based on ocean monitorings of various parameters, indicators, variables. And this is key when writing a story and generating science-based, data-based illustration. Thanks a lot for this very comprehensive presentation. Now I invite you to go back on Slido as we have a question for you. And the question is, what communications challenges are you looking to address with the Copernicus Marine Service data? I've seen that some have already raised their concerned question in the chat box on the Slido question and answer, but I invite you now to fill out the Slido. I've read from the previous chat box that there were algae bloom, change of temperature, making ocean data attractive, of course, to the general audience, make them interested in ocean issue. That's quite key these days with the UN Ocean Decade on water temperature. Yes, making hard data easy to read for non-professionals, data stories, having reliable sources, data for graphics and visualizations. I do see that we are good in terms of feeding your concern and challenges within the workshop today. So let's move forward as we are all looking forward to hear how we can use the My Ocean viewer. Let me introduce our next speaker, Elena DiMaggio from Mercator Ocean International. Elena holds a Master of Sciences in Earth Sciences and Planetology. She is currently working as a technical support manager in the Copernicus Marine Service. Her main activities are focused on the success of customer activities, feedback, and internal technical improvements. She helps end users, meaning you today, our audience, to choose the best marine product for their needs, access, download, and process data in Python, Julia, MATLAB. Elena, welcome this afternoon. Thanks for being with us.
Hello, everybody. Thank you. So yes, I will start. I will show you My Ocean Viewer, what we provide as I move this. has visualization tools. So you can access them, as Pyrus show you, from the Copernicus Marine homepage that we have here, the catalog, the stage report, the indicators. Here we have the box for the ocean visualization tools. When we click on it, we access the 3 tools that we provide. They depend, the use of one of the other depends on the objective you want to achieve. We have a first one, which is the Measure Learn. I have it here, which is more for beginners. We have a globe where we can move, we can zoom a bit to focus more on the variable. We only have here on the left 6 variables issued all from numerical models. Our variables have been chosen for you from our experts. And you can see that we have a short animation about the evolution of these variables in the areas concerned. In this case, of course, for the sea ice, we have the poles, we have the Arctic here, and if we move, we have the Antarctic. We can also choose, for a better visualization, a planisphere. So we move to the 2D map. We have the same GIF. We can stop it if we prefer and focus on a specific step. We can change, of course, the variable. And if we want many other information, we can click on Learn More. And we have all the info, or the main info about this product, the product use. Of course, we have also some use cases where the product is used. So do not state if you are not sure. If you want an example, is a very good way. And we can keep watching and we can explore. Unfortunately, when we are on a 2D map, we cannot zoom over a specific region. We can only have this view that I'm showing you, but can be useful for users to make it more easier to your readers. And of course, if you want to know how to reference Copernicus Marine, you also have the credits. So do not hesitate to check on it. So this is the beginner tool. We have the Measure Light, which is an intermediate level, let's say, where we have directly the planisphere. Here, when we click on it, okay, we have a planisphere. We can move on the map if we like. We can zoom over a region, which is very useful if you want to focus on over a small region or for coastal data. And we can see also that we have quite more variables. Before we only had the main ones like temperature, salinity, velocity, and so here we also have the winds, which are ocean surface winds, which is a bit loud to charge. We have the pH, which can be useful to check the status of the ocean, and also the dissolved oxygen for the acidific, for the oxygen in the ocean. It's a bit slow, it can happen, no worries. It depends on the charge of the server. So here we can explore, as I was saying, we can explore the map. We cannot go to the poles. It means that we cannot change the projection. Here we have the equatorial and that's all. But if we move to the sea ice variables, we have the poles automatically, the Arctic projection with the sea ice at the Arctic, and we can switch to the Antarctic. Now I come back to our variables, nicer. Okay. Here you can see in the bottom of the page, here you have a timeline. This timeline, it covers 2 years of data, which is the, as Paris was saying, is the period available for our models, the forecast models at minimum. And we have we can change the date. So here we have a static map, but you can change it. I can select the day we want to focus on. Like, for example, if I want to study this typhoon, I guess, we can start, we can zoom on it, explore. We can also create an object when we click on it, we create an object which is a point, and automatically a graphic showing the evolution of winds in this point is created. So we can already have an overview over the 2 years of data of the evolution in this specific area, this specific region. Again, it's quite long. And you can create as many points as you want. So for example, if you have several stations, you have the exact coordinates, you can create the points and study the evolution of the variable on the points. You can hide the graphic if you like, and you can also delete it if you don't want. And you can add other graphics, which means that you can change for some variables. You can also change here the layer you want to explore. Okay, if I move to the temperature, which is a variable that has values, vertical values. So if the winds are only at this sea surface, we can go deeper in the ocean if we want. We can go deeper in the ocean, we can change the depth level we are observing. Here, by default, at the beginning is 0, so we are at the surface, we are observing the sea surface temperature, but if we go a bit deeper, we can start seeing, first of all, that of course the temperature is decreasing, and also we see where the bathymetry starts playing a role. I can delete all this, will be easier. So, especially near to the coast, here, if we go a bit deeper, again, we start seeing the ocean ridge, and so on. If we want a very specific level, we can zoom on the depth bar. The same for if we want a specific day, we can zoom on the timeline. I'm doing it with my mouse. I'm scrolling with my mouse, but you can also do it by using shortcuts that I will show you. So here I want precisely 1000. Here I am. Or I can simply come back to the surface. You are free of doing whatever you like. And if you want to save this image, for example, or you want to share the link or to make it available to your users, you can click here on the share button on the left. You can share the link with your colleagues, or even save it as a bookmark. This link will directly redirect you to the exact same map you were observing. So if I create some graphs or graphics, or if I zoom over a region, and after I decide to share this link, I will have exactly the same page if I open it in another browser, or if I pass it to a colleague. We can also export an image, and we can log in if you are logging in. As we say, the Copernicus Marine Service is free of charges. However, for the moment, there are still some functionalities that requires you to be logged in. I will do it to show you how it is. So you can create a video. It can be an MP4 format or a GIF. You just select the time range you want, the start and the end date, the steps if you want an image every day, every hour, week, month, or year. The best here is in function of the product you are using to, of course, adapt the time step to the resolution of the product. It's better to use, if you want a month, it's better to use daily data. If you want to explore an year, it's better to use monthly data, and so on. And you just select the parameters you want. You create on generate video. It will generate here. I left it by default, but it will generate your video, and you will be able to download it. You will do it. In the video, you will have, as you see, the color bar, so the legend, and also here on the bottom, the time step and the depth level. So it will allow you to know what the time step you are observing, and also if you are at the surface or a bit deeper in the ocean. It's a bit longer than expected. Anyway, doesn't matter. You will be able to download the video. Now, what is very interesting for you if you have a vlog or if you have a script or if you just want your users coming to your own page, to your web page, exploring the data, here you have an embed link. With the embed link will allow you to have exactly the same interactive map for your users. So from your web page, they will have access to the MyOcean viewer, to the variables you decide, or even the other variables, and they can zoom in and out, move in the map, create objects. They will have exactly the same interface that you have from the MyOcean Lite. For the shortcuts, you only have to click on the eye. Here you will have the keyboard shortcuts, which is useful if you are on a laptop in general, and you will have, of course, the credits. Now, if you have any question, of course, you can contact us. You click here on Talk to an Expert. A chat will be open. Here we are available to answer to your question, or you can just access to the full viewer. You click on it, and we are here passed to the MyOcean Pro viewer. The MyOcean Pro viewer, as you saw, has the same functionalities as the Lite, but some others that can be very useful. If in the Lite and the Learn, we choose the variables for you, we choose the time range, we choose the type of product. So if it's a model, satellite, or in situ measurement, here you are free to do whatever you want. It means that you can access the catalog. You have the 1,275 products. You can explore all of them. You can choose, you can filter and choose what you like without any problem. If you are logging in, you can also export the data themselves and not just an image or just a video or just a link. You will be able to export in your local disk the netcdf file that composes the data, and everything is free. So, from your questions, let's say, I will stay on the temperature just to show you. I will stay on the surface scientifically. I will not enter too much in the details, so I stay on the surface. I will stay on the temperature to speak about the ocean warming. When you click, of course, here you can filter your data. Sorry. I will do it. Let's take the temperature. You are coming from across the whole globe, so I will stay on the ocean, on the global ocean, even if you have some regional data that has higher resolution. So if you are choosing a coastal product, or if you are interested on a specific region, I suggest you to choose a regional one. It will be easier for you with higher resolution. And I will want daily temporal resolution. We have here a series of a choice of products. We have 9 products providing matching these three parameters I filter. We have models, we have satellite observation, and we don't have in situ data because we don't have it at daily resolution, but we also have in situ data if you're looking for them more specifically. I will stay on my models, but I will take the multi-year ones, which covers from the data from 1993 to 2020. So we will explore here a time series. And when you click on it, you have the overview with all the information, the notification if there are any issues ongoing with this product, the data access. In the moment you will want to get the netcdf file, so you want to export the files in your local disk, you can choose the accesses you want. If you are not sure, if you don't know, you can click on the eye and you will access this is here. Sorry, I lost it. You will access, here I am, the Help Center. Our center, where we have several articles, around 200, to answer to all your questions. If they don't answer, you can contact us, but you don't have to stay to check it out. And finally, the contact. Of course, as I say, you can contact by chat, the chat I show you, by online form, which is a contact us, and or by email. If you want any details, you can check the documentation of the product. We have the technical documentation, the user manual, where we have the variables described, the variables available, the structure of the dataset themselves. We have the scientific document, which is the quality information document, where we have the validation, we have the observation used in this case as input for the model. We have the results, we have some focus on some variables if we decide to justify the results and so on. And finally, if you don't know how to cite the product, you're not sure, or you need a better reference, we also have an article here, how to cite, where we give some examples on how to cite the Copernicus Marine products. So, sorry, come back. If I'm sure with the product after reading all the details, I can click on Add to Map. Here I have different datasets. The main differences for these datasets is the temporal resolution. I have daily, monthly, also climatology, and the static. The static corresponds to all the information we need to know about the grid, as is a model in this case. Of course, there is a grid that had been built from zero. So in the static, we have all these informations. Now I want to stay on the daily, and I have the list of variables contained in the dataset. And we can see that we have several variables. So I can also, if I decide to change, I can also add several variables from the same dataset. There is no problem with that. Or remove if we are not sure. And we access our map. Here, we see now that we have two layers. The first layer is my multi-year products providing data from 1993, and the second is the forecast corresponding, providing data in the last 2 years plus 10 days of forecast, which means, and today that we are the 21st of June, we have data until the 1st of July. Can be useful if you are interested in studying predictions and so, but in this case, I will focus on the other one in order to have an evolution over the years. So now, of course, my timeline is in the present or close present, so is in 28 September 2021, but our data for this product arrived in the 31st of December 2020. So I have to move on my time. Okay. Here the same, you can move on the map. You can also change the projection, for example, which it was not possible in my ocean light. To study the poles, you can come back to the equator if you prefer to go on this projection. And if at the same time you can create objects like points, you can also create some lines if you want to study the transect. Again, automatically some graphics are created, and you can also study an area. The area will give you some histograms where we have the frequency, a value appears over this area in this timeline, in this time step, which means that, for example, here I have 25 degrees. The main temperature for this region are around, I don't know, 23 to 25, where we have more than 50, the majority of our data. More or less, we can see that over the region, the temperature is around these values. If we like, we can export the graphic as CSV. This CSV will help you to reproduce the graphics here we are seeing, and or you can just export the graphic itself and see the SVG, which is not working for them. Good to know. So if I do it with a timeline, it will be better. The SVG, just to show you, here I am. So here in red, we have the time steps, and the rest is the temporal evolution of our variable. Now, finally, of course, as in the learn, I didn't say, but as in the light, you can change the timeline, you can zoom on it, you can the same for the depth. You can compare, as we were saying, you can compare some other variables between them. So if you want to study the correlation between two variables, when we speak, for example, about temperature, we always speak together with salinity. So it will help you to compare some of them. To compare two variables at the same time, you can play on the opacity. So now we don't see it, but now here I'm playing with the opacity. You can play also on the color map. Here we have, for each variables, we have some color maps, some palettes that are by default, but you can change them if you want to focus more to help the visualizing some phenomena. You can also change the minimum and maximum values, and or mask out of range the values that are not in this range. So for example, here I only want the minimum starting at 10, whatever is under 10, I delete it, I hide it. And finally, what can be interesting, not for today, for this workshop, but in any case, in the future, of course, it will be to download the data. When we speak about download, it's really defining a region or defining an object, or it can be a point itself. We define the date range by the widget calendar or as in map. When you click as in map, you will be choosing the time step you selected in the timeline on the bottom, and the elevation range. If you, of course, exceed the one limit of gigabyte, you will have an error. You will need to change, to adjust your needs here, for example. Still. And you will be able also, here we have the temperature, but I was saying, I want, for example, the salinity for the same product, the same period, the same region. And so we can also select several variables from the same data set. Of course, we will change the size, so we'll have to adapt. You can click on that when it's adapted, you click on download, you get the files directly on your page, on your disk. And finally, of course, the same as before, the share options. We have to share the link, download the image, download the video, and finally, to copy the embedded link with all your users to explore exactly the same data as you want. And that's it. As I was saying, if you have any questions, do not hesitate to contact us. There are several articles. We have another video where you can write here a message. We have another video with another example in the help center. So if I just check, I give you a short demo. Here we have a function of my search the article. And you have here another example. So we have some examples and videos in the majority of our articles, so do not hesitate. And of course, if you don't have your answer or you need more details, which can be scientifically or technical, if you need help with your scripts, do not hesitate. We are here to help you.
Many thanks, Elena, for this fascinating presentation. I think we can all agree that My Ocean Viewer is a life-changing tool for our storyteller and also science communicators. It provides quite an extensive range of usage. And as one of our participants said, it provides a complete product range and need practice. So you've promoted the help desk, the user support. You're part of, Elena is part of the user support. You have the Learning Center, the guideline, the quality info doc, but please do not be scared to use My Ocean Viewers and get acquainted with it. The replay will be available from this demo available next week. You will have plenty of time to review the demo and practice, and we're going to have in the second part of this workshop a practice training. But before we move to that practice, let's go back to some questions. I think we've received questions about the catalogs for Spiros, also on the MyOcean viewers for Elena. Spiros, would you like to take in the question, or Andrea, the questions about the catalog?
I'm not actually familiar what the integration is referring to. I'm not sure that I can answer this question.
Yes, I can answer in a very broad way. What I can say is that in situ data is definitely used to validate satellite data and also model data, and is also used in our models to make it more accurate to what we want to predict. For example, that's what we use to validate. It's the in situ measurements, so the direct measurements of the temperature, chemistry, etc. And vice versa, I've heard, but I'm not an expert on modeling, so I wouldn't be able to explain you exactly how they do it, like to validate each other. But if that's what they mean by integrated, yes, yes, that's all I can say.
Thanks for this precision. Please be aware that other questions will be shared after the workshop with the various responses and experts' input. Do we have time for a second question? Do we keep the waves data archive, please? Are they available? Will one of you respond taking that question?
Or the waves? With,
The
I'm sorry,
archives?
which?
The archives?
Yeah, the wave archives.
Yeah. Because I think
we have,
sorry.
No, sorry. We have some archive of wave data. I mean, we have data covering starting from 1993 as the same. They can be a model or satellite observations. So it depends after what you mean of wave data archives. But if you, I mean, you can contact us. If the data from 1993 are not enough, we can contact the producers and see if they still keep the data for the validation. Depends on the region and so.
Yeah, I think that because I saw that questions, related questions about the timeline. I mean, until which date can MyOcean viewers go?
Sorry, I'm not sure I understood.
Yeah, there was someone in the chat box, and I think it came quite regularly, is the timeline MyOcean viewers cover, the period.
Depends. It depends on the products we have. The longest is from 1987 to nowadays, but it's adapted to the products we have. So the longer is the period, the best our MyOcean will do.
I think due to time, we're going to move on to the practice session, the second part of our workshop now. I'm sure that all of our participants are eager to know how to use the Copernicus Marine data to build a story. Spiros, I think you've prepared a case study for us, and I'm sure, and I will ask, I'm sure our audience to get ready to take on that training with you along.
Yeah, I've prepared a few examples of how this data could be used for news generation. I'll have a brief presentation again with various examples and use cases. And after that, we'll do, I think, 3 practical exercises on how this data could be used and match them with the appropriate story, story with the appropriate product. So, in this presentation, I'll start with a simple question like why data visualization is important. I think this is an easy answer. It's a very common saying, a picture is 1,000 words. And this is especially true when we're talking about geospatial phenomena, which have a temporal extent, they are always evolving. So Copernicus, Marine Copernicus services and the products and the tools that Elena presented you have various intuitive ways that you can use them to build your story or support it. But first and foremost, understand that these phenomena are complex data. Most of these, at least, are very complex data, and a lot of variables, oceanographic variables, are involved and play part on how the things go out. For example, we're talking about acidification, but this acidification is happening because another factor plays in, like the carbon dioxide. So having this type of catalog with all these variables, it's very we need to gather them and see how we can integrate them to build a story. We can have interactive exploration, which users can interactively explore and visualize the data and get familiar with those. Another very important part is the temporal coverage that I think there is also a question about. Users having this big time series, users can go back and see what was happening in the past. And also very important thing is also get reference points. For example, you see something that's happening right now, but you're not sure if this is normal or not. A very easy way to see what is normal happening is to go another year back at the same date and see what was happening at that time. Go back 2 years and you see that the past years nothing was happening and now there's something there. So temporal coverage is actually very, very important. And of course, we saw how this infographics and maps that can be produced can be very useful for putting the message across and describe this kind of phenomenon. Now, continue with some examples and use cases, like how you can support publications with Copernicus Marine products. The first example here is from Daily Sabah, a Turkish, I think, newspaper or magazine. And here they interview a marine scientist about the trend of the sea surface temperature rise in the Black Sea. And it is stated that the average sea surface temperature of the Black Sea is rising in the past years at approximately 2 degrees Celsius. And how can we, of course, this is true, but we can visualize this phenomenon and this trend very easily with the various infographics that Copernicus Marine Service has in the trends and the indexes, indicators section. For example, this map was taken from that section and shows the trend of the SST, the sea surface temperature accumulation from the last 3 decades. And we see exactly what was stated in the article, that in every part of the Black Sea, there is a rise of at least 2 degrees of Celsius. Next. Thank you. This is another way you can use this data to create new stories from scratch. For example, this is a GIF that was made for this workshop for the seasonality of the sea ice coverage in the North Pole. And this kind of gives very light information, very striking in some cases, can be used to inform your audience for various phenomena, either harmful or normal phenomena, but they should be educated about them, or explain those phenomena. And you can discover the scale of things. What does this mean? Is that you may see something at your local beach, or have with your boat something, a phenomenon. You think it's regional. You go suddenly to a platform like Marine Copernicus, you see the data, you see the general region, and you see that this phenomenon is not limited to your area. It's broader. So that's a very useful usage of this kind of services as well. And of course, the other slide, I'm sorry, can I go back? Thank you. The other is a screenshot taken from the ocean report the previous year, and it shows with a simple graphic the extent how, for example, it was what the ice coverage was the last few decades and what is now. And you can take information from these kinds of reports, which are written by multiple scientists, to get informed yourself, and after that build a more informative and comprehensive article using this kind of data. You can see from them what they use to describe this phenomenon. Okay, thank you. Next. Perfect. And with those kind of tools that Elena presented you, it is very easy, as you understand, to make a map for a near-time event and post them to social media like Twitter, Facebook, etc., whatever you use, to put a message quickly across to a broader audience. This, for example, an image, I think, from Sentinel-2 high-resolution imagery for sargassum growth and spread. And the other one is for a marine, using the Copernicus Marine products of temperature, showcase a heat wave in the Mediterranean. Okay, next slide, please. Okay, and now I'll show some use cases. This is the first one is the more extended one. I'll try to make it sound like a story. I don't know if I succeed in that. And it's about marine mucilage, also known as seasonal. But before I begin, I'll say a few words about what this phenomenon is. Basically, seasonal are extrusions from algae, organic extrusions from algae. And when the algae is in high concentrations, it can extrude a lot of this material, and it can produce sticky blankets over the sea surface, like the gentleman here that tries to clean up. And this kind of material, the seasonal, is actually quite common in the oceans, but when it happens in a lot of very quickly in small places like enclosed gulfs, it can cause severe problems like the one presented in the image. It can limit the light passes through the water column, and that can limit the photosynthesis that's happening by seagrass. It can cause oxygen depletion from the decomposition of phytoplankton and the organic material, which can again affect severely marine life. And also a lot of economic hindering, either by tourism. It makes a very unsightly phenomena. It's very smelly, and you don't want to swim in a beach full of that seasonal. And of course, it can have, if it's too severe, it can affect fisheries due to these mortalities. Okay, next slide. Now, this story started in April 2021 in Sea of Marmara, Turkey, a very enclosed marine region. It's connecting the Aegean Sea and the Mediterranean with the Black Sea. Can we move one slide, please? Perfect, thank you. Huge concentrations of seasonal were observed on April 2021. And here is an article by The Guardian, accompanied with various measurements from the Sea of Marmara, which show the scale of the problem. Basically, the whole Sea of Marmara was full of this kind of material, and caused in many cases also anoxic conditions, and had severe effects both on the marine ecosystem and also the maritime activities. Now, if we move a few months later, basically 2.5 months forward, in the middle of the summer, the seasonal started to go to escape the Sea of Marmara through the Dardanelles Strait. It's the red arrow that I show here in the map. And the first occurrences in the North Aegean Sea happened. This story, the other article, is the Limnos, for the Limnos Island, encircled island on the map. And the first stories came in about seasonal appearing in the northern Aegean Sea. Again, similar situation. It's not that enclosed the Gulf like the Sea of Marmara, but I can tell you if we go to the next slide, that the problem was very severe indeed, even though it was almost open sea. Here are some examples using imagery from the Sentinel-3 Copernicus Sentinel-3 satellite mission and the Sentinel-2. Sentinel-2 is the middle one, which is a high resolution, and some UAV data taken from the scene at the day that a few days after the phenomenon broke out. So you can see the scale of things, like in the UAV data, you see that the stripes of seasonal. These are a small sample of these stripes, and you can see that it disappears in the horizon. These stripes actually engulf the whole island of Limnos for 1 week and some days later until the phenomenon disappeared. But it engulfed the whole island. And you can see also how this phenomenon can be observed with Sentinel-2 imagery as well as with Sentinel-3 imagery. It's not that clear with Sentinel-3 imagery if you do not know what you're looking for. But again, you can see clearly some of the white stripes escaping from the Sea of Marmara to Limnos Island. And now we'll see, because these are big data and maybe hard, they are hard to work with if you're not familiar and you don't have an interest to learn how to work with. We'll see a very easy way to see something like that through Copernicus Marine data. And as I said, seasonal is produced by phytoplankton. And phytoplankton is, because it photosynthesizes, also chlorophyll in itself. So we can use chlorophyll concentration as an indicator to see or measure the concentration of seasonal in the water, or at least observe how this phenomenon develops through time. And we'll use this particular dataset. It's the same that I explained in my previous presentation about chlorophyll in the Mediterranean with 1 kilometer spatial resolution. Okay, let's move one slide forward. Perfect. And here we have a reference year. Here nothing happens. Here is the normal state of phytoplankton, of chlorophyll concentration in the North Aegean Sea, the previous year before the seasonal outbreak happened. And we see that in the majority of the region, we have very low concentration values, which is actually what is true for the region, because the Aegean Sea is very oligotrophic. It has very little nutrients, and that does not allow the development of high phytoplankton population growth. Instead, we have a few areas with high concentration of chlorophyll, but these areas, there are 3 areas, I believe, the Gulf Thermite, Postrimon, and Evros. These are coastal regions where major estuaries are located, and these rivers wash out a lot of nutrients to the sea, and they produce a lot of chlorophyll. A lot of food for phytoplankton to grow. Now, if we move 1 year later, this is the months, the days of the seasonal outbreak. We immediately see, if we observe, it's the same GIF, the same time rates from 1st of June to 15th of July to 2021. And we immediately see how this phenomenon it can be observed from this kind of data and the scale of the problem, because I must remind you that the only articles that we managed to find about this phenomenon was from Limnos Island, which I don't know if you remember through the map. It's kind of in the middle of the region here. In the other parts, we didn't see, no seasonal was observed, but if we take a look at the satellite observations, we can see that we had a lot of chlorophyll concentration, which is abnormal and unprecedented for the area. And that could cause potentially other kind of problems, like eutrophication and stuff like that. But here I can see that what I want to present is a very easy way, like this GIF. If you get familiar with the platform, you can make yourself in matters of minutes if you know what product to look for. Now let's move to another example, different kind of example. This one, the article is in Germany. It is about a storm surge that flooded the city centers of various cities in the north there in the Baltic coastline for Germany. And the article reports that at the day of at that particular night, the sea level had risen about 1.83 meters above normal. This is an article from BBC. It was for January 5th, 2017. And let's see what products can we use to visualize that kind of phenomena and see also the scale of it. If we move another bit, okay, perfect. Here I used this product. It's about sea surface height above sea level, SSH, in short. It's a numerical model with a spatial resolution of 2.2 kilometers. Now, the image on your left hand, it's for January 3rd and 2015, and the image on your right is for January 5th, 2017. January 5th, the right side image, is the day that the flooding happened. And just 2 days ago, you can see through the map that no abnormal sea level rise was observed. But just in 2 days, the models picked up that increase of the sea level. Now, this kind of problems like coastal flooding to storm surge, you can use, you can try maybe to use other variables like wave heights or wind information and products. I decided to showcase this one, but you can try to, you should not be limited to just one variable to look into a phenomena. You can play with it and ask questions through the academic world to make a catalog to what you can use for its particular area and particular phenomenon. Okay, and another one, this is the last example, I believe. This is a different kind of article. This is from National Geographic and Ocean Acidification. This is a different article because it doesn't speak, it doesn't talk about a particular event, a particular harmful event or phenomena. It's more for educational purposes. It talks about the ocean acidification and its causes, what it can affect, how it can affect our oceans, and etc. And it explains how this the acidity of the ocean is affected by the carbon dioxide from our atmosphere. Basically, our oceans are a big well that absorbs steadily carbon dioxide from our atmosphere, and it's trapped in the ocean. And actually, oceans help cleaning our atmosphere. But that causes other problems to the oceans because carbon dioxide lowers the pH steadily of our oceans, and it causes them to acidify. Now, again, something like this very informative article, if we move on a slide, we can use, again, products from the trends and indicators section of data access. This map shows the trend of the pH values, how it changes across the decades for the global ocean. And what we see here, immediately see that there is no positive value on the color scale. And if you look into basic chemistry and pH, you'll know that material with lower pH values are more acidic, and those with higher pH values are more alkaline. So if the trend is to pH to get lower, then we can see that these parts are becoming more acidic. And through this map, we can see that this occurs for the whole extent of the global ocean. And again, we can use, supporting the previous article, other infographics, like the graphs on the right hand. The top one is about the flux of total CO2 that is absorbed by the oceans. and the bottom one again is the pH trend. So the pH trend is decreasing every year, but the carbon flux is increasing. So we can just showcase this inverse relationship between the flux of CO2 and the pH trend through just these two infographics. And I think that was the use cases I had to present. And now I think we'll move to the practical exercises. Natalie.
Yes, I think it's a time for our audience to get ready and test how they can use the Copernicus Marine data to write and extract a picture. As you all understood that through the three case studies on this note, sea level rise and coastal flooding, ocean acidification, the Copernicus Marine data provides a life-changing tool to inform, educate, explain the phenomena, and discover the scale of that phenomena. And we're now going with Spiros to go through a practical training. So please embark and make sure that you follow step by step what Spiros is going to invite us to do. Thanks, Spiros.
Now, the first thing is to use the link that was provided in the chat. And here you will be asked to match two articles with the appropriate product or map and variable. Here, for example, it says it's talking about a marine heat wave, and you need to choose what you think is the most appropriate map that describes this article. You can decide. I'll leave you a few minutes, and then we'll discuss the answers very briefly, and then we'll move to the other exercise.
I think most of our participants should have filled the choice of their favorite by now, Spiros.
Read both articles.
Please choose the right or the one you think is the most correct one. Thank you.
Do you think you're okay, Natalie?
Yes.
Okay, this first exercise, I don't think it was too hard. Basically, the first article, though, talks about it's very fresh. Actually, it's happening these few days. I think it started last week or something. I'm not sure. It's about a marine heat wave along the coastline of the United Kingdom and in Ireland specifically for this article. So when we're talking about a marine heat wave, immediately we try to think temperatures, and the correct answer is for C, which is the sea surface foundation temperature for the specific region. Okay, I'll move to the next one, I think. This article refers to the algae blooms that occur on the northern Arctic Ocean, and how it can affect possibly the fish and the marine biology of the specific area. Now, algae blooms are directly related to chlorophyll concentration. That's how we can monitor them through satellite observation. So the correct answer is A, where this a very big algae bloom was observed in, I think, 2017, if I'm not mistaken. It says it on the bottom. Yes, 2018. So the correct answer is A again. Okay, we can move, I think, to the other exercise, which is more practical, where you can follow along. Just to make a map that supports not an article. We will make a map that supports a specific article, which then I think you can use for your publication. So the article says that sea surface temperature in the Mediterranean seas the last summer is increasing. It says specifically between May and August of 2022, the Western Mediterranean Sea and region experienced at least one marine heat wave, which the sea surface temperature anomalies reached 4 degrees Celsius. Now, here it doesn't say sea surface temperature, it says sea surface temperature anomalies. And what these anomalies mean, it refers to that we try to calculate what's abnormal about the temperature. Basically, we take the climatological mean, what is usually happening in an area, and then to compare it with the near real-time data. And we see the anomaly. For example, if we have higher resolutions today than what's normal happening, then the anomaly will be positive. If it's less, it would be negative. So let's try to make a map for this particular case and article. So start my share screen. I hope you see my screen well. So in order to do that, we'll go to the ocean visualization section. And here we have the 3 tools that Elena presented us in her presentation. To get more familiar with the products, the tools, we'll try to use the MyOcean Pro tool. You can click here to access it, map, and we can start with a clean slate just by removing all the preloaded data. So we're trying to find, try to visualize the marine heat waves for the Mediterranean for the summer of 2022. First, let's zoom to the area of interest, which is the Mediterranean. And now we'll try to populate this map with the appropriate data. We can click here to add a specific layer. We immediately see all the data catalog of Copernicus service, and we can start doing research for finding the appropriate product. For example, we're talking marine heat wave, so we must select temperature as a variable. The area in question is the Mediterranean Sea. So we'll check this product, this filter option. After that, we can select the temporal resolution. Because we want a specific data, I select a daily spatial resolution. And then after that, we can select level 4, so don't everything doesn't have gaps due to cloud coverage. It would be more appealing to the readers. And maybe I'll use satellite observations. And I'm left with just 2 products out of 275. Now, the difference between these, the first and the most important, I think, is the spatial resolution. This product offers higher spatial resolution, just 0.01 degrees, and this one 0.05 degrees. So I will go with this one, which is ultra high, gives ultra high data resolution. Sorry, skip the thing. So if we click here, before we go to add it to our map, we can see that it provides SST at high resolution and at ultra high resolution. And also provides level 4 data of SST anomaly for the same resolutions. So we also have SST and SST anomaly. We talked about previously how SST anomaly can be used to showcase what's abnormal in a region. So try to visualize that particular product. So when we click to add to map, we can see all the data sets and the variables they contain, as Elena showed us. The first 2 is about the temperature anomaly, and the others are about the sea surface temperature itself. We'll work with sea surface anomaly, as we said. Now, if I add both of these products, I'll see the differences of them. It's about the spatial resolution that the product description was talking about. So I've zoomed in Sikelia, and you can see that the first product that I've selected, which I believe it's the it's the 004D, has the finer spatial resolution. So I will work with that. Now we have selected our product and the marine region. We have zoomed in where we want. We want now to go see the specific time range that the event was happening. So it was between May and August of 2022. So let's see some particular date, for example, let's see 1st of June for this region. And we see that immediately most of the marine regions in the Mediterranean Sea are colored red, which says that we have a very high SST anomaly in an area. The degrees here are more than 4 degrees Celsius higher than the climatological mean. So we can have an indication that, okay, yes, I can see the heat wave with this kind of data. Now, if I would like to visualize it, I would just take this image, and go back another year. So here I'm on 2022. We can go again 1st of June 2021 now. I'm here. So go just here. And you'll see that the previous year, we didn't have this kind of positive anomaly or heat wave the specific date. But I think a more interesting way to visualize this phenomenon is to see its temporal extent and how it is evolving. So we can try to make a GIF or a video from this data set. So the article says that the heat waves began from start of May 2022 until the end of August 2022. So I can just put here these dates, 1st of May 2022 and 31 of August 2022. Now I'll select that to make it a GIF. And because there's a lot of images, I can skip a few for the visualization purposes and choose a 1 week step. So every day it skips 1 week, and each frame is another week. I can make it this however long I want. I'll make it 12 seconds, and then I can generate the video. Now you get the idea, you can follow along. You can see how this phenomenon is evolving, but you can try to make it yourself. We have also the correct answer and how it should look like in our presentation. So I think I'll stop sharing here. After you finish, you can of course download and use it.
Many thanks, Spiros, for this practical exercise. You hear me? Yeah?
Yeah, I'm sorry if it took too long. I think I took a lot of time from the workshop.
I think it's very important to understand, I mean, for audience, journalists, and science communicator, how to generate a story and visual using the Copernicus Marine data. That's really essential. So the next step, if you write a story, or if you want to illustrate your story with the right visual, is to move on with the social media. Our next expert for today is Simo Madis. Simo is an enthusiastic communication professional with demonstrated experience in online and offline communication and with a flair for events. Simo has a solid experience in communicating complex topics such as satellite navigation and Earth observation to a broad range of audiences. Other interests include EU affairs, space technology, environment, and languages. Simo, the floor is yours. Do we have Simo with us now?
I see that he's having a connection problem. He will probably be back in a second.
So while we wait for him, I will just reassure our participants today that the recording of today's workshop will be made available on the Copernicus YouTube channel from next week, that everybody will receive the form that has been used to do the demo as well in their inbox. Is Simo back with us now?
I think
Yes, I
not.
am. Apologies.
Great.
There were just
Perfect.
some
Welcome
technical
back.
issues. So yes, if I just
I think we lost again Simo. As we wait for him, you should also be receiving, I'm doing some housekeeping information at the same time, for time purposes, you should be receiving soon in your inbox the full article that has been generated today on heat waves, together with the appropriate visual. So you can relax and wait for those in your
I am
inbox.
back.
You're back. Thanks,
I am
Simo.
back again. Great. So thank you, Spiros. Once you got your story published on your media outlets, which we will hope you will do after, the next step is to push it further so you generate the clicks and the engagement that you want. So here we have prepared a few tips and tricks of how you can make your posts that use Copernicus Marine data a bit more engaging. So we would like you to consider the following before start the copywriting. So the first one would be to set an objective. Social media is an environment where users meet there to converse and to exchange views. It's not always about making announcements. So think of how you can ignite the conversation online. Think of the answers that you would like to see below your social media post. The second one is to use captivating images, visually striking images. And with my Ocean Viewer, as Spiros and Elena explained before, you have the possibility to extract images in a JPEG and PNG form, and short videos or animated GIFs. The latter, GIFs and the videos, have the best result in terms of engagement on social media, which is why we would suggest that you opt for these two. The third one is you have to know your audience. So if, for example, your readership is purely technical scientists, then the tone of the post that you're going to generate has to be a bit more serious, let's say. Likewise, if you're targeting a general public audience, the tone can be a bit more friendly. And last but not least is a call to action, which will be the link to your story. And to complement on that, studies have shown that adding emojis, not many, but 2 or 3 on your social media post increases the likelihood of a click. So emojis are good to be used from time to time. And then if we can move on to this next slide, we're going to show you 2 examples of social media posts. So the one is a bit more friendlier. So building on what Spiros presented, we took the visual and we tried to describe it so users can then click onto the article. As you will see here, we try to sound a bit funny, but at the same time we keep the balance by mentioning that according to Copernicus, we back it up with the data and with the expertise coming from Copernicus Marine Service. Then if we move on to the next post, we will see that here it's even more serious. So here we refer to the global warming as a root cause of the rise of the sea surface temperature. And then again, we use words such as ocean experts to make it sound a bit more serious if you want. And then if we move on to the next and the final slide, what is very important for us is that you try to use as much as possible the following hashtags and that you tag the following accounts. The reason behind is that, first of all, you help the Copernicus Marine Service and the Copernicus program overall to increase their brand awareness on social media. The second very important reason is that once you use the EU Space or the Copernicus Marine hashtag, your story will appear below this hashtag on a timeline, and this increases first of all the likelihood of other users with similar interests clicking on your post. Which is something also very important. And then a last point that I would like to make is that our colleagues at Mercator Ocean or the European Commission or the Copernicus Marine Service, they monitor all the tags, all the times that they have been tagged. So they will make sure to retweet and give you extra visibility. And why not reach out to you? That applies mostly for the journalists. So using both hashtags and tags is a win-win situation, both for the Copernicus Marine Service, but also the journalists. And this is where my presentation ends, and I'm going to go back to give the floor to Spiros.
Yes, thank you.
Just a final note that I made for these presentations. Basically, what I would like you to take home from this workshop is, first of all, the importance of visualizing spatiotemporal phenomena with spatiotemporal data, and how this phenomena can be monitored through satellite and model data. Is, of course, you cannot learn just from one workshop, but you can get an idea on how you should look into those kind of stuff. Basically, you see a phenomenon, you need to make your research on it, or contact some local expert on the phenomenon, and then you know that you have various products through Copernicus Marine Service that you could potentially visualize those phenomena. Visualize them through this RIS library that we present you here today, and also it provides the tools that you can very easily produce the appropriate graphics that you can support your story or publication. That was my final note for this workshop. Thank you again very much for your attention.
Thanks a lot. Thanks a lot, Spiros. I think it's really important to go back home and emphasize on the importance of visual data and illustration. And as also Simo emphasized, it is important to optimize the social media impact by using the right and the most efficient Copernicus Marine data and referring to the right hashtag. Before wrapping up, we have a few questions on the Slido, and I think we'll take the 2 or 3 questions, more particularly aiming to Spiros and the demonstration practical case he has provided us today. So yes, we have 2 questions, I think, Spiros, for you.
Okay, for the first one, actually, I'm not that familiar about the ice products from the Marine Copernicus, but I'm sure you can try to visualize for a specific date for monthly data, for example. You can take a try to take a screenshot for one specific specific date or time period this year, and try to compare it with data from 5-10 years ago, if you can find the product with the appropriate time span or time coverage. Again, I'm not that familiar with the ice products, the ice coverage products from the Copernicus Marine Service, so I'm not exactly sure that I can answer it correctly. If Andrea can put some input in this question, it would be actually pretty helpful.
Yes, I would have to check the viewer actually also to know that. I don't know it from the top of my head, but yeah, if the participant wants to know more information, you can also contact us if you have a specific need on a date or something like that. We can try to see if we have that data, and make it available to you as well. Yeah.
Now for the next question, let me read it briefly. I'm not sure about the longest heat wave period, what you're referring about. Basically, when you're seeing you saw the SST anomaly in these products, if you read the documentation of those, they state which is the reference year that they take, that like the standard climatology for the specific product. So if you make the comparison through just the SST anomaly analysis, you can write what is the reference for the previous years. I'm not sure if I understand correctly the question. The last one, specifically logins heat wave period, that's the one I don't know exactly how to answer. Maybe it counts the days that the heat wave lasted. I'm not sure about that.
I'm sure, Spiros, that complementary information and response can be provided by the team today and the Mercator Ocean International experts once we send out after the workshop the responses to the series of questions that have been put on Slido or in the chat box, just to reassure everyone who is participating today.
Just to complement a bit the previous question about the ICE products, if it wasn't clear enough, it is true that we have ICE products. Now it depends on the time you're looking for. Of course, it's limited in time, but we do have ICE products, just to be clear. You can check on the viewer and explore the Arctic and Antarctic data we have.
Yeah, there are products. I saw the GIF that they produced for this workshop already.
You showed it previously.
Slides.
Exactly.
Yeah.
No, the products are there, but I'm not exactly sure how they can be used to produce a graphic like the one that is in the ocean report that the question was referring to. I'm not familiar with those products to answer that question specifically.
Thank you.
Thank you for this precision. It is really important. So we come to nearly the end of our 2 hours workshop on ocean literacy for journalists and science communicators. Before to wrap up and give the last word to Andrea from Mercator Ocean International, I have to thank first all the audience who has taken the time to be with us today, and also our experts, as I think it's been a fascinating journey to get to acquainted and understand how we can use Copernicus Marine data to write a story and generate the right visuals. Andrea, may you
Thank you.
to have the last words for today?
Yes. Thank you. I wanted to thank to all of you, Spiros, Natalie, Simo, Elena, who have participated, gave us such a nice input today. And I wanted to address every participant. If you're a communication expert or communication, someone who works in communication, if you work in a newsroom or something like that, you can also contact us via our user support, as Elena showed. If you're in doubt of which product to use in your communications, you can contact us, and we will try to give you the expert support on that. So yeah, we are available. As we said, we make data available to you, and we also provide support. So yeah, we are, and as Natalie said, all the recordings will be available on the YouTube channel. And we will also send you an email to all the participants with some resources from this workshop today. So the articles you've had access to, and the GIFs created as well by Spiros, and some extra information. So yes, thank you everyone once again, and we see you in our next workshops. So stay tuned. Bye bye.
Bye everyone. Thank you for your
Thank
attention.
you.